Myself Dr.P.Vijayakumar, Associate Professor, Department of Electronics and Communication Engineering, Aditya University. Today's session we are going to see problem solving on functions related to random variables. So at the end of this particular session, we will be having learning outcome 1, understand and work with the functions related to random variables. So in the earlier sessions we have seen the functions related to random variables. There are 3 functions. First one is probability mass function, second one is probability density function, third one is probability distribution function. So in this session we are going to see the problem solving on all these 3 functions. So we will recall what is meant by probability mass function. Probability mass function is nothing but probability of P of random variable x is equal to small x. And also we will recall the properties of probability mass function. The properties of probability mass function are the probability of any value is always greater than or equal to 0, and the sum of all probabilities defined on the random variable for x, let us say, must be equal to 1. So we will use these 2 properties in solving the problems. In a similar manner, in the probability density function we have got 4 properties. The probability density function is always greater than or equal to 0. Area under probability density function is unity. And if you want to compute the probability lying between any 2 values, so the formula is probability of x1 less than x less than x2 is integration of the density function over that limits. Okay. So these are some properties of probability density function which we are going to use in the problem solving session. And also one more function is the cumulative distribution function. We know that the cumulative distribution function is mathematically defined as probability of x less than or equal to x. So in the problem solving we will use the probability of x1 less than x2 is equal to fx of x2 minus fx of x1. So these are the few properties which we are going to use while solving the problems. So while solving the problems, once again we will recall the properties. Okay. Let us see the first problem which is related to probability mass function. As already mentioned that the probability mass function, probability of any element which is defined must be greater than 0 and the sum of all the probabilities must be equal to 1. So we will use these 2 properties here in solving the problem. So the data is given something like this: x is equal to some xi, x is equal to some xi. So for 0 the probability is 0, at when x is equal to 1, k, 2, 2k, like that up to 7 they have given the probability corresponding values. So now they asked us to compute the value of the constant k. So we will use this property. The sum of all probabilities must be equal to 1. Using this property, 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k. So all these probabilities values must be equal to 1. So k plus 2k, 3k, 5k, 8k and 9k. And this is totally 10k square. 10k square plus 9 is equal to, so we are equating it to 1, 9k, 10k square plus 9k minus 1 is equal to 0. So this is the quadratic equation we got. So when you solve this quadratic equation using the formula minus b plus or minus b square minus 4ac by 2a, so we will get the answer. One answer is k is equal to 1 by 10. So generally the probability is positive. Probability should be positive. We will choose the value k is equal to 1 by 10. So k is equal to 1 by 10 is the constant unknown value. And next we are asked to compute the probability of x less than 6. So x less than 6 includes this probability of x equal to 1, 2, 3, 4, 5, all these values should be calculated. So k plus 2k plus 2k plus 3k plus k square, all these values. So this is equal to 8k plus k square. So that is 8 by 10 plus 1 by 100. So you will get approximately 0.81. In a similar manner, probability of x greater than or equal to 6. That means we need to include probability of x is equal to 6 plus probability of x is equal to 7. So 2k square plus 7k square plus k, 9k square plus k. 9k square means 9 by 100 plus 1 by 10. So 19 by 100. So this value is 0.19. So this is how we can compute the unknown values of k, and also we can compute the probability for the given probability mass function with the help of the properties. The properties are p of xi greater than or equal to 0, summation of all probabilities defined on the random variable x is equal to 1. Let us solve one more problem related to the same concept. So the data is given like this: the probability mass function at 0, 1, 2, 3, 4, 5, 6. The corresponding probabilities are k, 3k, 5k, 7k, 9k, 11k and 13k. Values are given to us. So firstly we need to compute the value of the k. So if we want to compute the probability, firstly I need to get the value of the k. We know that the sum of all the probabilities is equal to 1, as we discussed in the earlier problem, the property. Using that property, summing all the values of the probability and equating it to 1, I will get k is equal to 1 by 49. And next one is probability of x less than 4. So probability of x less than 4, how many values are there? 0, 1, 2, 3. So x equal to 0, 1, 2, 3. That means k plus 3k plus 5k plus 7k, 12, 15, 16k, 16 by 49. In a similar manner, we can compute probability of x greater than or equal to 5. So probability of x greater than or equal to 5 before proceeding. So given the values up to 5 to 6 only. So probability of x greater than 5 means x equal to 5, x equal to 6. 11k plus 13k, which is equal to 24k, 24 by 49. And one more problem is given to us: probability of x lying between 3 to 6. So 3 is not included here, 3 is not included here. So it must be greater than 3, 4, 5, whereas 6 is included. So 6. So that is equal to 33k, 33 by 49. Next one is they are asking us to compute the minimum value of k to satisfy this condition: probability of x less than or equal to 2 must be equal to 0.3. As per the problem, probability of x less than or equal to 2 is x equal to 0, x equal to 1, x equal to 2, k plus 3k plus 5k, which is equal to 9k. So as per the given requirement, 9k should be greater than 0.3. That means k should be greater than 0.3 by 9, that is 3 by 90, that is 1 by 30. So the k value should be chosen as k greater than 1 by 30. The minimum value is 1 by 30, the value should be greater than 1 by 30 to satisfy this particular condition. So next problem is related to the cumulative distribution function. As already mentioned, that the cumulative distribution function is mathematically defined as fx of x is equal to probability of x less than or equal to x. So we need to compute the cumulative distribution function, and also we need to express the cumulative distribution function as the sum of shifted versions of unit step function multiplied with its corresponding probability. Also we need to compute we need to sketch the cumulative distribution function, and also we need to compute the probability density function. We know that the probability density function is derivative of cumulative distribution function, and the probability density function also can be mathematically expressed as summation of p of xi del of x minus xi, sum of shifted versions of impulse signal. So we will see these plots at the end of this problem. So firstly, we need to compute the cumulative distribution function and its mathematical expression. Using this, we can compute small PDF, that is probability density function, and we can plot the probability density function value. So the question is being asked like this: a coin is tossed 3 times. When a coin is tossed 3 times, the total sample space is 2 cube. So when a coin is tossed once, head and tail. If it is tossed thrice, so 2 into 2 into 2. So the total sample space is 8, which is equal to 2 cube. And the possible outcomes in the sample space are, these are the combinations which are possible when you toss the coin 3 times. So first question is, write the sample space, description space. So the sample space consists of 8 outcomes and the description is like this. All 3 heads, 2 heads followed by tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, all tails. So these are the all possible cases. Next, given that x is the number of heads in each of the outcomes of this experiment. X is the number of heads in each of the outcomes of this experiment. So the probability of getting head. So they have given equal probabilities. Here the probabilities are given equal probability. Okay. When it is getting 0 head, the probability is 1 by 8. 1 head, how many chances for 1 head? 3 chances, so 3 by 8. The probability of getting 2 heads, again we got 3 chances, 2 heads combinations, 3 combinations are possible, 3 by 8, and all heads combination is possible as 1 by 8. Okay. So already they have given the probability, defined the probability, okay, 1 by 8. Using that probability, we calculated the corresponding probabilities when 0 heads, 1 head, 2 heads, 3 heads. So later on we need to compute the cumulative distribution function. So we know that the cumulative distribution function fx of x is equal to p of x less than or equal to x. So first I will compute fx of 0, that means p of x less than or equal to 0, which is equal to 1 by 8, 0 heads. Fx of 1 head, fx of 1 is probability of x less than or equal to 1, that is probability of x equal to 0, probability of x is equal to 1. So combining 1 by 8 plus 3 by 8, 3 chances for 1 head, 1 chance for 0 head. So I will get 4 by 8. In a similar manner, fx of 2, probability of x less than or equal to 2 means 0, 1, 2. So 0, 1 by 8, 2, 1 head 3 by 8, 2 heads 3 by 8, totally 7 by 8. And fx of 3 is probability of x less than or equal to 3. The summing all values will be equal to 1. So now we computed the distribution function. So the distribution function can be mathematically expressed as summation I is equal to 0 to 3 p of xi u of x minus xi. So this is the distribution function. This is the sum of shifted versions of unit step function. At 0 its value is 1 by 8. At 1 its value is moving to 4 by 8 with an increment of 3 by 8. At 2 its value is moving to 7 by 8 with an increment of 3 by 8. At 3 its value is moving to 8 by 8 with an increment of 1 by 8. So when you connect all these points, clearly it looks like a increasing staircase function. So this is the mathematical equation for this function. So if you do the derivation for this one, doing the derivation, small fx of x will be summation I is equal to 0 to 3 p of xi del of x minus xi. So this will be the sum of shifted versions of impulse function. So at probability of x is equal to 0 is 1 by 8, del of x is 1, probability of x is equal to 1 is 3 by 8, del of x minus 1, probability of x is equal to 2, del of x minus 2, 3 by 8, probability of x is equal to 3, del of x minus 3, and its corresponding probability is 1 by 8, 0, 1, 2, 3. This is the density function plot and this is the distribution function plot. Okay. So we used the definition of relationship between density function and distribution function here. and also we plotted the graphs for distribution and density function at the end. Okay. Now let us see the problem related to the probability density function. We know that the probability density function is mathematically defined as derivative of distribution function, or else if you want to compute the distribution function from the density function, you need to do the integration, vice versa operation. Integration of density function provides you the cumulative distribution function. Okay. So, based on the requirement, we use these two formulas. Here the problem is given like this: the probability density function is defined and x is a random variable and whose values ranges from minus infinity to plus infinity. We are asked to compute the cumulative distribution function for the given density function, and also we need to develop the relationship between a and b, and also we need to compute the probability when x is lying between 1 and 2. So, the density function is given. We know that the absolute value of x is equal to x when x is greater than or equal to 0 is equal to minus x when x less than 0. Using this property, the function can be rewritten as a power b into x, because absolute value of x is equal to minus x when x less than 0. Minus minus combination will be plus, and absolute value of x is equal to x, and the function will be a e power minus bx for positive values of x. For negative values of x, this is the formula. Now we need to compute the distribution function. We know the distribution function is nothing but integration of density function. So, using this formula, for x less than 0, let us compute for x less than 0 connection, x less than 0 combination, minus infinity to x. Assume x is which is less than 0. Now integration of e power bx. Integration of e power bx is e power bx by b. So, replacing that and substituting the limits, e power x minus e power minus infinity. E power minus infinity is 0. So, the answer is for x less than 0, the distribution function is a by b e power bx. Similarly, when x is greater than or equal to 0, so minus infinity to 0, 0 to x. So, two cases are possible. Minus infinity to 0 is one split, another split ranges from 0 to x. So, minus infinity to 0, the expression is a e power bx. For positive values of x, a e power minus bx. So, doing the integration and substituting the limits, I will get a by b 2 minus e power minus bx. So, the distribution function for negative values of x is a by b e power bx, for positive values of x is a by b 2 minus e power minus bx. And the next problem, they asked us to compute the relationship between a and b. We know that any density function is a valid density function if area under the density function is unity. If area under the density function is unity, we can tell that it is a valid probability density function. Using this property, let us develop the relationship between a and b. So, minus infinity to infinity fx of x dx. So, minus infinity to 0, the function is different, and from 0 to infinity, the function is different. And doing the integration, what you will get 2a by b. This should be mathematically equal to 1. From this, a by b is equal to 1 by 2, or we can write b is equal to 2a. So, this is the relationship between the scalar quantities a and b. And next question being asked is, we need to compute the probability lying between 1 to 2. So, we can use the property of density function. If you want to compute the probability lying between any two values, we need to compute the area under that particular strip for the density function. So, the density function area should be computed over these limits, we will get the probability value. So, 1 to 2, the density function expression is a e power minus bx. Because x is positive, the a e power minus bx should be availed here. So, a e power minus bx, we know the integration of e power minus bx is e power minus bx by minus b. substituting the limits 1 to 2, and we will get a by b e power minus b e power minus 2b. So, we know that a by b is equal to 1 by 2, we will replace it with 1 by 2, e power minus b minus e power minus 2b. So, the complete answer is in terms of b. Also, we can express in terms of a. Okay. So, this is the probability. Let us see one more problem related to the distribution function now. Okay. So far we have calculated the directly using density function. We will see another way to calculate the probabilities using distribution function, and we will use the distribution function properties also. The cumulative distribution function is defined here from ranging from minus infinity to plus infinity, and we need to compute the constant value a. We know that the cumulative distribution function fx of infinity is equal to 1. This is one property which is available with us. So, fx of 4, this is the upper limit possible, fx of 4 should be equal to 1. So, when the function x value is equal to 4, the distribution function is a into x minus 1 is equal to 1. Here x is 4, a into 4 minus 1 is 1. So, a is equal to 1 by 3. So, this is the constant for distribution function, scalar value. This is based on the cumulative distribution function property. And one more problem is asked, probability of x greater than 2. We know that the probability of x greater than x can also be computed as 1 minus probability of x less than or equal to x. That is nothing but 1 minus fx of x. So, using this relation, p of x greater than 2 can be expressed as 1 minus p of x less than or equal to 2, that is equal to 1 minus fx of 2, fx of 2. So, this is the equation I need to use. 2 lies between 1 to 4. So, I will replace x with 2, a into 2 minus 1. A already we computed 1 by 3 into 2 minus 1. 1 minus 1 by 3, we will get 2 by 3, the probability of x greater than 2. And the last one, probability lying between 1 to 3. Again we got one more property in a cumulative distribution function. If you want to compute the probability lying between any two values, the formula is fx of x2 minus fx of x1. Using this formula, probability of 1 less than x less than or equal to 3 can be written as fx of 3 minus fx of 1, and fx of 3 falls in this expression only, a into x minus 1, that is a into 3 minus 1 minus a into x minus 1. 1 also falls in that formula range, I mean that prescribed range. So, a into 1 minus 1. So, this is equal to 2a. We know that a is 1 by 3. So, the probability for the given range is 2 by 3. In the earlier problem, we used the concept of probability density function for computing the probabilities and for finding the unknown quantity scalar. In this problem, we used the properties of cumulative distribution function. All properties play a very key role in solving the problems. So, the moment you apply the property, you can solve the problem very easily. And so, we solved all this one. So, already mentioned that we can also solve the same problem using density function. See here, the same problem can be solved using density function. So, the distribution function is given as a into x minus 1 over the range 1 less than x less than 4. We know that the density function is derivative of distribution function. The density function is derivative of distribution function. When you apply the derivative, the density function will become a 1 less than x less than 4. So, if you want to compute the unknown value a, we use the property valid density function. We need to verify whether the given function is a valid density function or not. Area under the valid density function is 1. Using this one, a over the range 1 to 4 dx is equal to 1. A into 3 is equal to 1, a is equal to 1 by 3. So, the same answer we got earlier also, okay, using distribution function. the same value you will get using density function. Similarly, if I want to compute probability of x greater than 2, so the density function is defined over the limits 1 to 4, the minimum limit is 2, the maximum limit is 4. The area under this particular density function 2 to 4 fx of dx, so constant is a, so x is the integration, so substitute in the limits a into 4 minus 2, so 2a means 2 by 3. In a similar manner, if I want to compute the probability lying between any two values, the area under that strip is the formula using density function. We solved in the previous problem, the same method we follow here, 1, 2, 3 a dx. So, that is ax 1, 2, 3. I will get again 2a, that is 2 by 3. So, in both ways we can solve, whichever is comfortable to us, whichever is convenient for us mathematically, we can apply that. We can solve using distribution function, we can solve using density function. We can use both properties in solving the problems. The thing is, we need to memorize the relationship between density and distribution function, and if you know the properties clearly, you can apply any property for solving the problem. Any method is okay, but answer must be unique. So, in this session what we have seen is, we have seen different functions related to random variables. So, one function is probability mass function, another function is probability distribution function, or sometimes it is also called as cumulative distribution function, and also we have seen the probability density function. So, all these three functions are related to random variables. So, in one session we have seen the definitions and properties of distribution or density function with one example. In this session we have solved comprehensive number of problems for probability mass function, distribution function and density function. So, in the next session what we will see is, we will take different random variables like binomial random variable, Poisson, Gaussian, exponential or uniform, and we will solve more problems, comprehensive number of problems related to those random variables. Okay, thank you.